Hey, okay, let's get ready to represent this recurring decimal as a fraction. We're going to take it in 3 simple, straightforward steps. Step number 1, what we're going to do is we're going to write out a series. In other words, we're going to take this recurring decimal and write it out with individual terms. Step number 2, then what we're going to do is we're going to put it into this sum to infinity formula and create an infinite geometric series. And then finally, we're going to transform it and express it and simplify it as a fraction. So let's go ahead and start off. But first of all, let's start to understand what this recurring decimal looks like. It's 0.47 repeated. The dot is over the 7, meaning the 7 will continuously repeat. So allow me to write this up in the way that it looks. So if this was to be written out, it would basically be so the recurring decimal is strictly on the 7, not the 4. So if we were to write this out as individual terms, it would be 0.4, that part, plus 0.07 plus 0.007, 0.0007, and so forth and so on. So if I was to sum these terms, and they are individual terms which form a series, we would have 0.47777. So that 7 will repeat itself just like up here, the recurring decimal. So these become our individual terms that we can express as an infinite geometric series. That's the first thing we want to do. So let me just mark out the terms. So the first term is 0.4, second term, third term, fourth term, etc. But because we want to express it as an infinite geometric series, we cannot use 0.4 as the first term. And do you know why? Because 0.4 is not recurring. So the first term that recurs is 0.07. So I'm going to change this now, rubble them out, and write down the first term as, right there, 0.07. Second term, 0.007. So the recurring part is the part that's in the series that we're going to put into an infinite geometric series. But first, let's write down the data of what we have from this series. So we have the terms. So the first term, A, is equal to 0.07. And the common ratio of this geometric series is R is equal to, let's go U2, 0.007 all over U1, 0.07. Dividing them together, R, the common ratio for this particular series is, so we have our first term and we have the common ratio. Now that we have them, we want to find what the infinite geometric series is. And we're going to use a formula that we're all familiar with. It's right over here. Let's do a recap. Sum to infinity equals A, the first term, over 1 minus R. So let me go ahead and drag and drop these values into this so we can come up with that series. So let me just write it up across over here. We have sum to infinity, and that equals, okay, let's put up the first term. The first term is 0.07, 0.07. That's the first term. So that's our A, 0.07. Let's put it up here. All over 1 minus the common ratio. Again, the common ratio is 0.1. And that equals 0.07 all over 1 minus 0.1 is 0.9. Now that's our fraction, however, it is in decimal format. So what I'm going to do is I'm going to multiply top and bottom by 100 in order to move that decimal point to the right. So let's multiply by 100, multiply by 100. Let's do that. Now this is going to give us a sum to infinity. And that's going to equal, on the top, multiplying by 100 is 7. Multiply the 0.9 by 100 is actually 90. So that's our fraction, but only from U1, from the first term here. This excludes the actual first term, which is the 0.4. Now we're going to bring that and add it here. So we're going to have 7/90ths, and we're going to add them together. So let's write 0.4 now. 0.4 as a fraction is, and we're going to add that to 7/90ths. And that's going to give us our fraction, our simplified fraction for this recurring decimal. So lowest common denominator, let's see, 90, 10s in that go, 9 4s are 36, plus 90 into that 1, plus 7, 36, plus 7. Adding them together gives us a value of 43 all over 90. So that's our fraction. Therefore, the recurring decimal, 0.47, I'll just write it again here, 0.4, and the 7 repeater is equal to and there you go, guys.